Section 3.7, example 50, evaluating an improper integral over an infinite interval. So evaluate from negative infinity this time to 0. And we have this sort of function. So state whether the improper integral converges or diverges. I wonder what it is. Okay, so let's see. The limit as x, not x. This time we're going to approach from a. So the limit as a approaches negative infinity, so starting off at the negative infinity, we're going from a all the way up to 0, 1 over x squared plus 4 dx. And let's integrate this. So this looks familiar. I kind of feel like it's a trig problem. Let's do a reference triangle. So I know that this is going to end up being tangent because we don't have any square roots. Don't have anything funny going here. So tangent is opposite over adjacent. So that's going to be x. And this is going to be square root of 4 is 2. We'll call this theta. So we could say that tangent theta is equal to x over 2, which means that x is equal to 2 theta, or 2 tangent theta. Let's take the derivative. So the derivative here is going to be secant squared theta, d theta, and that's going to be equal to 1 over 2 dx. I feel like we have everything now, so let's go ahead and start. So the limit as a approaches negative infinity from a to 0. So we'll switch it back to x once we finish with theta. And let's see, so from a to 0, and we have 2 tangent theta squared plus 4 in the denominator. And in the numerator, we have this right here. So secant squared theta and d theta over here. So the limit as a approaches negative infinity from a to 0 for tangent squared theta plus 4 over, and actually this should be 2, because if we multiply both sides by 2, yeah, we would get that. Okay, so 2 secant squared theta d theta. I'm going to factor out these. I'm going to factor out a 2 here, and I'm going to factor out a 4 here. So factoring out all that stuff, we have 2 over 4, the limit as a approaches negative infinity from a to 0, secant squared theta over tangent squared theta plus 1 d theta. And it looks like this ends up being secant squared theta. We have secant squared theta here, so we could divide those two. That ends up being 1. So bringing that 1 over 2 back in, let's say that the limit as a approaches negative infinity from a to 0 of 1 over 2. That's just this reduced. I wanted to bring it back in so we had something to integrate. D theta, that gives us the limit as a approaches negative infinity. 1 over 2 theta, evaluated from a to 0. A to 0 came from the original problem, so let's turn this back into an x. So theta is equal to, we could think of it here, theta is equal to tangent inverse of x over 2. So tangent inverse of x over 2. The limit as a approaches negative infinity, 1 over 2 tangent inverse of x over 2, evaluated from a to 0. So now we could evaluate. Limit as a approaches negative infinity, 1/2. We have tangent inverse of 0/2, or we could just state this as 0 minus tangent inverse of a being negative infinity. All right, so when is tangent inverse equal to 0? So sine, we'll say sine theta, cosine theta. So when sine is equal to 0, will this inverse part be 0? So when is sine equal to 0 on its interval? It's going to be here at 0. So this part goes to 0. And here now we're looking at tangent inverse of actually negative infinity. So I could tell you what the solution is, but let me just show you what it ends up being. So this here is the graph. Let's see if we could. So this here is a graph of tangent inverse. There we go. It's a graph of tangent inverse of x. So see, as we go further and further towards negative infinity, we get really close to whatever this line is. So let's grab this and see where it is. It looks like it's pi halves, but just to make sure, let's see. We'll say y equals pi over 2. Y equals pi over 2. Oh, actually negative pi over 2. There we go. So it looks like we approach that as we start going further and further to infinity. You could see it as we start getting further and further. We approach it, but actually never cross it. But as we go to infinity, the limit as it approaches infinity approaches that pi over 2. So what we have here is 1/2. That's right, 1/2. We have 0 minus a negative pi over 2. This ends up being plus, and it ends up converging to pi over 4. And there we go. That's our solution. So they ask the question, state whether the improper integral converges or diverges. So we would say that the integral converges to pi over 4. And that's our solution. Now, if you have any questions, please feel free to ask. Otherwise, bye.